Okay, so we were discussing how the manometers work. Okay, we said that if we have a tube filled of mercury and we turn it in a reservoir of mercury, what will happen is that we'll create here a certain vacuum space. And because you have a very low pressure at this level, this will lead to evaporation of mercury from the tube towards this space until reaching steady state conditions. When steady state conditions will be reached, then you will have like vapor of mercury here. And if you measure the pressure here, we call it vapor pressure. So we can say that at equilibrium, the pressure here will be equal to the vapor pressure of mercury. But we can measure experimentally that this vapor pressure is really small. It's nearly zero. And this is good. Why? Because if we want to measure, for example, the pressure of the room using this device, okay, how to do this? We know that uh, the pressure of a static fluid will not vary horizontally. So if we move on this surface horizontally, the pressure will not change. So we can say that the pressure at these points, which is the atmospheric pressure, is equal to the pressure at this point, which is at the bottom of the tube. Okay. And we should look what do we have above this point. So to determine the pressure at this point, because if we know the pressure of this point, we can measure the atmospheric pressure or the pressure in the room. We can say that this point is present below a certain height of mercury, H. So if we name this point 1, okay, we can say that P1 is equal to, since we have a height of mercury H above this point, so the pressure at point 1 is equal to rho of mercury times G times the height of mercury in the tube, plus what? Plus the pressure at this level. And we have seen that the pressure at this level is equal to P vapor of mercury. But because P vapor of mercury is really small, close to zero, I can neglect this term. So I can read then the pressure in the room by just knowing what is H. This is why you can see these devices, they annotate them so you can read H, and H can be directly converted to pressure, okay? Because if we write that P1 is equal to rho mercury times G times H, so they can directly graduate the scale. They multiply the height by rho mercury times G to give you directly a reading of the pressure. So this is the concept of these devices that are used to measure pressures. Okay. Now we'll see
But
other
what happened
types. Yes.
if we put a tube filled with mercury in a bowl full of water?
Okay. So this is not. This will be very different. Okay. And because the analysis will be more complex, because you cannot anymore say that I am moving in the same fluid. So it depends. We'll take some other examples to see how to do this. But you can, if you have water and mercury at the same time, then you should see where is water, where is mercury to be able to do the analysis. I will take other examples to see what I mean. Okay. Let us consider other devices that are used to measure the pressure. For example, okay, let's say you want to measure pressure in a pressurized container. Okay, how to do this? You can, if you look at the figure here, you want to relate the pressure at A with the pressure in the atmosphere. Okay, so the purpose here always is to measure, let's say, your room pressure. You want to measure your room pressure and you have several devices. Here, in this case, in general, in the pressurized container, you know what is the pressure PA. So PA is known. And you want to deduce what is the pressure of your room. So when you put this device in the room, you'll have a certain change in height here. And depending on this change of height, you can deduce what is the value of PA. Let us see how. You always start from the point where you know the pressure. Let's say you know the pressure at A, okay? You say, I start from this level, the pressure is PA. Now, to go from this point to this one, okay, I should move downward. And as you can see, you have several fluids here. And you have fluid 1 here in this part, and in the container, you have fluid 1. Okay, and here, the pink color, you have another fluid, which is fluid 2. Whenever you have two fluids, you cannot move if you want directly. Yeah, if it was the same fluid, you can say, I will directly move from this level to this one because it's the same fluid. So if you have the same fluid, you have the right to go on the horizontal level directly and say the pressure at this point should be equal to the pressure at this point. And then you have only to see what do you have above this point. However, because here you have two fluids, you should be careful. You cannot move across when you have different fluids. Okay, so first you say, I am moving in fluid 1 downward. And what is the downward distance moved? H1 is equal to the difference between ZA and Z1, is equal to ZA minus Z1. Okay, so first you can say that I know the pressure horn at this level. I can say that P1 at this level is equal to PA, which is in the pressure in fluid 1 at this level. This is PA. And as I move downward a distance H1, then P1 will be PA plus rho 1 times G times H1. So now I know what is the pressure at level P1. Okay. Now, because now I have another fluid and I have the same fluid from this point until reaching this point. Okay. Then I have the right to say, let me jump across from this point to this one. Why we do this? Because if you move first downward, you should do plus rho 2 times G times this height, which is H2. Okay? And then as you move horizontally, the pressure will not change. And then you will move upward the same distance. Yani, when you move from this level to the bottom level, you have P1 plus rho of fluid 2 times G times H2. Okay? And then if you move up the same distance, you should subtract minus rho 2G times H2. So because you moved downward and then you moved upward the same distance, these two will cancel out. So this is why we say when we have the same fluid, we have the right to jump across. However, if we have different fluids, we don't have the right to do this because rho, which is the density, will be different. Okay, so now you can say from this point to this one, the pressure will be the same. It's equal to P1 since we are at the same level in the same fluid. Now, as I move upward, the pressure will decrease. So I should do now minus. So P2 is equal to P1 minus rho of fluid 2 times G times H2. And what is H2? H2 is the distance from this level to this one, which is Z2 minus Z1. And then I can find what is the pressure at this level. And since this level is open to the atmosphere, I can say that pressure of point 2 is equal to the atmospherical pressure. So what will be my overall equation? You can write it in one equation. You say, I started from point A, so I have PA. Then, since I moved downward in fluid 1, I add plus rho 1g H1. H1 is ZA minus Z1. Then when I reach this point, I can jump across until this point, so the pressure is the same. And to reach my final point, I am moving upward, so I have decrease in pressure. This is why I put minus rho 2g H2, which is Z2 minus Z1, equals to the pressure at point 2 that I want to measure. Okay? Any question on this? Another example, okay? If you have, for example, the following figure, and you want to relate the pressures at A and B. So let's say you know pressure at A, and you want to deduce the pressure at B, okay? So the method is always the same. I start from A. I have several fluids here, so I should pay attention, okay? We have here, in this part, you have fluid 1. From this point to this one, you have another fluid. So this is fluid 2. You can see from colors because you have different colors. This is fluid 3. And this is fluid 4. So you should pay attention when you go from one fluid to the other, okay? First, you say, I start with fluid 1. Since I move first horizontally, there is no change in pressure. Now I should move vertically downward a certain distance, H1, which is ZA minus Z1. So my pressure will increase. So I can say that PA plus rho 1 GH1. I am at this level. I found the pressure at this point. So the pressure at this point is equal to PA plus rho 1 G ZA minus Z1. Now I am in a new fluid. Since it's the same fluid here, I can jump across directly from this level, from this point to this one, since I am at the same horizontal level, so the pressure will not change. And now I say to go to this point too, I should move upward, so the pressure will be reduced. And since I'm moving in fluid 2, I should do minus rho 2g times H2. And H2 is Z2 minus Z1. This is H2. So until now, this term, okay, will give me the pressure at point 2. Now, after point 2, what do I have? I have a new fluid now. So, and since this is a one fluid 3, I can jump across until reaching this point because I am at the same horizontal level in fluid 3 now. Since I am in fluid 3, and now to go to point 3, I should move downward, then the pressure will increase. So I should do plus rho 3g times H3. And what is H3? H3 is the difference in height. It's Z2 minus Z3. So this term would represent until now the pressure at point 3. So until now, I reached this point. I know the pressure at 3, and I want to continue. Because now I have moved in a new fluid, this is the same fluid of density rho 4, I can jump across until reaching this level. And now I say to reach point B of interest, I am moving upward. Because I'm moving upwards, the density will decrease. So now I should do minus rho 4g times height 4, okay? And height 4 is ZB minus Z3. So now I reached point B, so I can say that the whole term is equal to PB. And if I care for the pressure difference, I can just take PB to the other side and say that PA to the other side. So PB minus PA will be equal to the summation of all of these terms. So it's rho 1 GH1 minus rho 2 GH2 plus rho 3 GH3 minus rho 4 GH4. So the method, I should always look if I'm moving down or up. If I move down, I increase the pressure. If I move up, I reduce the pressure. Any question on this?
What if PA or PB or both are open? Will the atmospheric pressure cause
Yes,
a
if
difference?
it's open, it's like the previous example. So if I give you this figure, if I put it like this, so you say when I reach this point here, the pressure is equal to P atmospheric. Then I can measure the value of P atmospheric. Okay?
How will the fluid move inside this if they
Same
are open?
concept, same. It's similar to this one. Then you go back to this device, نفس الconcept. It will move in a way to indicate what is the pressure PA, because the change in heights, okay, the change in heights will depend on the pressure that you impose outside. So you can vary PB. When you vary PB, the heights will vary. So if you put, for example, PB equal PA, you can find what will be the corresponding changes due to P atmospheric. Okay. Other question?
سوري مس بس بالبي 2 كيف
Yes.
كيف عملنا جامب اكروس وهو different فلويد؟
لا انت الجامب اكروس هون يا محمد، هيدا مش نفس الفلويد هير من هون لهون. It's the same color, so it's the same fluid, and you can jump from this point to this one. Okay, هون مثلا when عملنا jump across this fluid, because here we have the same fluid, so we can go from this point to this one. Okay, واخر شيء هون we have the same fluid, so we can jump from this point to this one. Okay? Other question?
بس انا بقصده اللي فوق الجامب اكروس هو
ايه بس انت يا محمد انت ما عم تاخذ، انتبه، هيدي الانترفيس، هيدي انترفيس بين تو فلويدز، اتفقنا؟ بس انت مش هون بلش الفلويد الجديد، يعني انت هون مش عم تمشي بنفس الفلويد هون.
صح.
اوكي، بما انه انت عم تمشي بنفس الفلويد، يعني الدنسيتي هي ذاتها، يعني انت بقى تنزل من هون لهون شو بيصير بالبريشر؟ بتزيد رو اوف ويتش فلويد؟ مش هيدا سميناه فلويد 2 نحن؟ اوكي؟
بلا.
انت اذا نزلت نزول بفلويد 2 مش بتزيد بلس، يعني بتعمل بي 1 بلس رو فلويد 2 تايمز جي تايمز اتش 2، صح؟ صار معك البريشر هون تحت. انت وقتها تمشي هوريزونتالي بتفرق البريشر بهذا الفلويد شيء لانه بعدك بنفس الفلويد؟ لا. وصلت لهون، هلا وقت بدك تجيب البريشر فوق شو بدك تعمل تجيب البريشر هون بهالنقطه؟ انت
هو ذات الهايت،
هو ذات الهايت وذات الفلويد، مشان هيك رح ترجع تعمل ماينس رو 2 جي اتش 2. يعني شو حيصير بهول التو تيرمز؟ ليش they will cancel out؟ لانه انت نزلت وطلعت بنفس الفلويد، يعني انت ما بدك تطلع هيدي الانترفيس، خلص شو بدك بالفلويد يلي فوق؟ ما نحن نزلنا بالفلويد ان بينك وطلعنا بالفلويد ان بينك، بما انه نزلنا وطلعنا بنفس الفلويد فينا نعمل جامب اكروس، بينما هون ما لك حق تعمل جامب اكروس. ليه؟ لانه هون بتكون نزلت بفلويد 1 وهون طلعت بفلويد 2، so we cannot do jump across from this point to this one. okay. يعني لأنه إذا بتروح من هون لهون ليش غلط؟ لأنه هون وقتها تنزل وقتها تزيد البريشر شو بتزيد؟ بتزيد هون بلس رو 1 H1. بينما إذا بتطلع هون شو بدك تزيد؟ بلس
رو 2 هون.
رو 2 H1 ما بيلغوا بعض. اوكي. So you cannot do jump across وقتها نكون عم ننزل بفلويد ونطلع بفلويد تاني. اوكي.
اوكي.
Other questions? Okay. Let us take another example. Sometimes you can use this device, okay, to measure pressure in moving fluids. Okay. So let's say you have a fluid that is moving between A and B, and the pressure of this fluid is varying. Okay. And you want to see what is the variation of pressure between A and B. So you can put this device, for example. Okay. هيدا مثل ما سأل أنطونيوس هون we can have different fluids. يعني هون the moving fluid, let's say, is water. Let's say we have water here, and we use, let's say, for example, mercury to measure the pressure variation. So this is mercury. So we should pay attention when we have different fluids. First, we say we want to measure the difference in pressure between this point here. So I will call this point 1. This is point 1. هني سموه A إذا بدكم. So A هو على center of the duct. Okay. And this is B at the center of the duct at this level. So, and we know that the diameter of the duct is D. So the distance from the center to this level is D over 2. Okay. Now, we are interested into the variation of pressure between A and B. So we say, let us start from this point. The pressure here is PA. Now, from this point to this one, I have the same fluid, which is water. From the color, you can know. So this is water. Because it's water and I'm moving downward, I should add the pressure. So I put plus rho of 1, يعني هي الwater. So this is rho water. Times G times. What is the distance I moved down? I moved first D over 2. Then I moved L. Then I moved H. So the total depth moved is D over 2 plus L plus H. Now, once I reach this point, now I reached mercury. In mercury, I can do jump across here, because here I go down in mercury, and here I go up in the same fluid. So I can directly say I can jump from this point to this one, because I'm moving in the same fluid. Now, for this point, okay, to go to next point, so if we want to go to this level, what do we have to do? We have to move upward a distance h. And since we are moving in mercury, we should put minus rho 2 اللي هي rho of mercury. Mercury symbol is Hg times G times H. Then we can find what is the pressure at this level. But we are not done, because we need to determine what is the pressure at B. So we say, to move from this point to B, what should we do? We should move upward again, but now we are moving back in water. Because we are moving back in water, we should do minus rho 1 times G times this distance D. And what is D? D is L plus the diameter over 2. So the final term will be minus rho 1G times L plus D over 2 equals to the pressure at this point, which is PB. In this way, we can find a relation between PA and PB. So what will be the pressure variation? PB minus PA. We have just to take PA to the other side, is equal to the summation of these terms. Okay. Question on this? Okay. Another example. Let us say also here, we want to measure what is the pressure at point B, for example. Okay. So what we can do is the following. We can relate the pressure at A to the pressure at B. Okay. So we have first, in general, such devices are used to measure the pressure of the moving fluid. Okay. The static pressure of the moving fluid. So my interest is to measure PA. This is why in general we know what is the pressure PB. It will be given, let's say, for us. And we want to determine what is the corresponding value of pressure at A. So we need to write a relation between pressure at A and pressure at B. So as usual, we can start from, let's say you can start from this point or from this point. It doesn't matter. Both methods will give you the same result. I will do both for you. If you started from A, okay, you can say I start from A. I have first PA plus. Now, first, if I move horizontally here, nothing will change because I'm moving in the same fluid, which is water. So I can jump, I can say that the pressure here is the same. Now, to go to this point, I should move downward in water a distance of 5 centimeters. So I should do plus rho water times G times 5. But I will convert to meters, yani times 5 times 10 minus 2. This is the distance I moved downward in water. Now I have another fluid. They told me that it is mercury. Okay, because now I have a new fluid which is mercury, I say I am moving here down and then up in mercury, so I can do jump across. I can directly go from this point to this one and say that the pressure at this level is the same. Okay, so no need to the 4 centimeter. I don't need it here for this stage. I just care for the 5 centimeter because now I will move up in mercury a distance of 5 centimeter. And because I'm moving up, I should reduce the pressure. So minus rho mercury, Hg, times G, times the distance. The distance is also here 5 centimeter. So times 5, 10 minus 2. Okay, I am done now. I reached this point. Okay, I reached this point. Now, after this point, what will happen? Guys, sorry, هون الفيجر شوي مش واضحة. بالميركوري مش 5 سنتيمتر لأنه طلعوا منيح. ال5 هي من هون. اوكي، بس هي تقريبا مبينة هي ذاتها بس مش هي ذاتها لأنه طلعوا هون عطوكم الديستانس هون to the top is 11. اوكي، 11 centimeters. يعني أنا if I do jump across، اوكي، هيدي الديستانس for a بضل height of mercury لفوق from this level to this one. I do 11 minus 4, it's 7 centimeters. Okay, so please انتبهوا على الفيجر. طلعوا منيح بالجيفن. يعني هون ال5 مبينة على نفس الليفل بس هي it's not actually because they gave us that the whole distance from this point to the bottom is 11, and we know already that from here to here where we did jump across we have 4, so the remaining part in mercury is 11. So when I move up in mercury I should do minus rho mercury times G times the height, which is 0.07 meters. Okay, after this they told me that in here I have oil. And I'm moving to reach B. I'm moving upward in oil a distance of 6 centimeters. So I should do minus raw oil times G times PB. Okay, and in this case, sorry, minus raw oil times D times H equals to PB, because I reached now the point of interest, which is point B. So in this way, I can write a relation from PA to PB, and since the only unknown is PA, I can find it. Let us do it in the reversed way. We can say we know PB. Let us start from B, for example. If we start from B, we write, we know first PB, it's given. Now we'll go to until reaching point A. First, we go downward in which fluid? We are going downward in oil. And when we go downward, we should add the pressure. We put plus raw oil times G. Okay, raw times G is symbolized in fluid books by gamma oil. Okay, this is what we call this value gamma. Okay, you can find it in books. The unit for it is Newton per meter cube. Okay, so gamma represents the density times G. So it's equal, if you want, to the corresponding weight per unit volume, if you want, Newton per meter cube. So plus gamma oil times H oil. H oil, we move downward in oil a distance of 6 centimeter. Okay, but don't forget to convert it to meter, and you multiply by 10 minus 2. It's 0.06. Now, once we reach this point, what can we do? We can say, I just need to determine the pressure at this point, because here I will do jump across and mercury. So to determine the pressure at this level, I'm moving down in mercury a distance of 11 minus 4, a distance of 7 centimeter. And since I moved down, I should add. So I add plus rho mercury times G, or I can directly say it's gamma. It's gamma Hg, gamma mercury. It's given. Okay. Times 0.07. So now I reached the pressure at this point. Now, to go to A, I need to move upward in water. Because I am moving upward in water, I should do minus gamma water times 0.05. And now I reached this point. And because this point is at the same level of A, so I can write that this should be equal to PA. And I will get back exactly the same result. If you replace, you can get the value of PA, which is here 96.4 kilopascal. Okay. Question on this? Okay. Next time, we'll do together buoyancy forces. How to determine buoyancy forces, which is the fluid of the force of a fluid on an object that is immersed in the fluid. Okay. Any question before we start?
Miss, here after the mercury is compressing, is going into the oil, where will the oil go? It doesn't have somewhere to go.
The oil is here, إذا بدك, it's a reservoir of oil. It's not moving. Okay. So here you have oil, and you can control its pressure, and you can impose a certain pressure at this point. Okay, you are able to control the pressure here. This is why we say that we know PB, and it's given because you are able to control the pressure here of oil. Then, and the oil is not moving here. You can consider that you have oil that is at rest here, and what is moving is only water. And you are interested into measuring the pressure of the static pressure of the moving water.
But when the water causes the mercury to move into the oil,
Yes, yes.
what
Look,
will
you
happen
have
to
a
the oil?
reservoir connected, and this is connected to a reservoir of oil. So if you
Okay.
need any additional oil, the reservoir will give you oil, so that so this can go down or up. Okay, this is connected to a reservoir of oil, and you can regulate the pressure at this level.
Okay.
Other question? Okay, see you next time. Bye bye.
Bye, doctor.
Bye.